Hey, fourth graders, Mr. Clean here today with our math lesson. And our objective today is that I can use a ratio table to multiply large numbers. So we're going to be building on what Miss Herman taught last time, kind of using ratio tables to solve multiplication problems and looking for patterns within ratio tables that can help you solve trickier problems. So kind of using the easier problems to help you solve the more challenging ones. And just to review, a ratio table, okay, looks like this. So it can be horizontal, side to side. I believe that's what Ms. Herman used last time. Or it can be vertical, up or down like this. And that's what we're going to be using this time, okay? They mean the same thing. It's just thinking about you're counting by a certain number, okay? You're using multiplication to be able to predict the next number. So in this case, we're going from 1 to 2, 2 to 4, 3 to 6, 5 to 10. So this ratio table is a times 2 ratio table because everything from top to bottom is times 2. 1 times 2, 2 times 2, 3 times 2, and 5 times 2, okay? And then this one over here, if it's a vertical ratio table, you go left to right. So you read it like this. So we're going from 5 to 15, from 10 to 30, from 45 or from 15 to 45. So the pattern here, this ratio table, is times 3. Okay. So sometimes ratio tables go in order like 1, 2, 3. But sometimes they don't. Like, look at this one. This one goes 1, 2, 3, and then instead of 4, it jumps to 5. Or in this one, this ratio table is counting by 5s on this side. So it shows us that as we're adding 5 here, we're adding 15 here. Okay? So you can look at ratio tables in lots of different ways. Now, for our problem today, we're going to be looking at a word problem that could be solved with ratio tables, okay? So here's the problem. It says, there's a sale at the store on cases of water. Each case contains 26 bottles of water. How many bottles in one case? 2 cases. How many in 4 cases? And then we have a series of numbers to do, 8, 10, 9, 199. So I'll start off with the first one, okay? One case. It tells us each case contains 26 bottles of water. So one case would contain 26 bottles. So far, so good. What if we had 2 cases now? Okay. So you could think of this like this is 1 times 26. And that equals 26. So I could do the same thing here. I could do 2 times 26. So I could think about it like that if I wanted to. I could think about how this is twice as big. From 1 case to 2 case, we're going to have twice as many bottles. So I could just add 26 twice. So I could add 26 and 26, I get 12 ones, 6 and 6. So that I'm going to put a 2 in the ones place and then a 10 up here for my 12. Now I have 2, 4, 5 ones there. So 52 bottles. Okay. Let's move on to the next one. How many in 4 cases? Okay. Now take a look. Again, we're doubling. To go from 2 cases to 4 cases. That's twice as many cases. So again, I could do multiply by 26, or I could double my 52. Okay, it gets twice as big from 2 cases to 4 cases. So I'm going to double my 52. 2 ones and 2 ones gives me 4 ones. 5 ones or 5 tens and 5 tens. That gives me 10 tens, which is the same thing as 100 and 0 tens. So that is going to be 104 bottles would be in 4 cases. Okay, let's move on to the next one. What about 8 cases? Okay, 8 cases of water. How many bottles is that? I hope you're seeing this pattern with me. Okay, because if I go from 4 cases to 8 cases, again, that is 2 times bigger. Okay, so I can make this twice as big. So now I'm going to add my 104. I'm going to double that. This is a way that a lot of smart mathematicians would solve these problems instead of trying to do 8 times 26. Okay? Because you could set up an area problem, an area multiplication problem, but this is the way that I would think about it. Okay? So 2 4s, that gives me 8 1s. 0 tens and 0 tens is still 0 tens. 100 and 100 is 200. So we're at 208. All right. Now we're getting a little trickier. Okay. Now we're going up to 10. 10 cases of water. Now let's see. Did we double again? Is that getting twice as big? No, it is not. 8 doubled would be 16. We're just going to 10. How could I solve this? Well, I could go back to my multiplication situation and think, oh, this is a times 10 problem. 10 times 26. Oh, I know my times 10s, because it's like saying 1 times 26, which is 26, and then making it 10 times bigger by adding a 0 on the end. Let me show you another possible way to solve this too. We were at 8 bottles or 8 cases of water, and that was 208 bottles. Now, if we had 8 cases and we added 2 more cases, that's 52 bottles. Let's add those 52 bottles. Let's see if we get the same answer. Let's see, predict. Are we still going to get 260? 8 ones and 2 ones, that's 10 ones. So I'm going to put a 0 down here and a 10 up here. That makes 10 ones, also known as a 10 and 0 ones. Now I have 5 10s and 1 10. It gives me 6 10s. And then I have 200s. Look at that. Got the same answer 2 different ways. Okay. All right, moving on. Oh, now we're going backwards. What if we only had 9 cases of water? Now, we can think about this in a few different ways. We knew what 10 cases was. What if we just took 1 case away? Okay. So we had 260 bottles. What if we take 1 case away? Let's take away 26. I'm going to think about this like a subtraction problem. Okay. So 0 ones take away 6 ones. I can't do that. I'm going to borrow from the 10. I'm going to make this 5 10s. And now I have 10 10s over here. 10 ones over here. 10 ones minus 6 ones is 4 ones. 5 10s minus 2 10s is 3 10s. And then I have 200s. So that should be 234. Let me show you one more way to do that. Okay. We could have also thought about it like 8 cases of water was 208. Add 1 more case of 26 bottles. Okay, and now we should have the same thing, 234. To speed it along, I'm not going to add it, but you can try adding it and you should get 234. Okay, last couple problems. What about 100 cases of water? Oops, let's reset that. see better. Oh, it's a little bit smaller for some reason. I apologize for that. 100 cases. So again, I'm going to use my same strategies that when I did times 10, but in this case, we're going to do times 100. Okay. So in here, I'm going to do 1 times 26 is 26. Now we're going to make it 100 times bigger. Okay. Or 10 times bigger and another 10 times bigger. So that should be 2,600 bottles of water would be in 100 cases. Now, what if we only have 99? Let's use our strategy about subtracting again. Okay. So what if we start with our 2,600 bottles of water, and now we have 99 cases. That's one less case. So I'm just going to take one less case away, which was 26 bottles of water. All right. This is a tricky one because I see I'm not going to be able to subtract my 1s or my 10s because I have zeros there. So I'm going to borrow all the way from the hundreds and make this 5 hundreds and 10 tens. Oh, this is going to get a little messy here. Now I got to borrow from my 10s now to pass it on to my 1s. So instead of 10 tens here, this is really 9 tens. And now I have my 10 1s. Now I can subtract. 10 1s minus 6 1s is 4 1s. 9 10s minus 2 10s is 7 10s. I have 500s left. And I have 2,000s. My answer should be 2,574. And isn't that a lot easier than doing 99 times 26? You could use the area method to solve that, but I think this method worked a little bit more quickly. Times it by 100 and then just take away 26. Okay? So let me show you what you can be doing today. In the Seesaw activity, you're going to click Add Response. So I'm going to do that. I'm going to be the sample student. Okay. Remember, the instructions are always up here if you want to see or listen to them. So it says, use the ratio table to answer question 1. So here's the first question. It's all these problems. 1 times 17, 2 times 17, 10 times 17, 9 times 17, and so on and so forth. Okay, I want you to try to use the ratio table and use some of the strategies that I was using here, okay, to see if you can answer these problems. All right, so I should see this ratio table marked up as well. All right, then after that it says, then use the label, the text tool, or the microphone tool to answer questions 2 and 3 on the second page. So you got to remember to click the second page here. And then here's our next couple problems. So you can answer these with the text tool by typing your answer. Okay, remember you can make a text tool bigger, you can stretch it, or you could click the microphone and record yourself answering the question. So 2 says, pick one of the problems on the previous page and explain how you solved it. You can type, talk, or draw. So you can explain how you solved one of these problems. And then number 3 says, Edie says she can solve 27 times 99 by solving 27 times 100 and then taking away 1 times 27. Do you agree or disagree? Explain. So that's your assignment. Please make sure that you click the green check when you are done. Good luck.